Hey, what's up, guys? This is Chung here again. So this time, today's daily challenge problem number 336, palindrome pairs. So you're given like a list of unique words and return all the pairs of distinct indices, right? And so that the concatenation of the two words is a palindrome, right? So for example, we have 4 words here. We have 5 words here, and the valid pairs are this because 0, 1, and 1, 0, if we concatenate everything together, they'll be palindrome, right? So that's it. Pretty straightforward, right? And so here's the constraint, right? So the length of the words is like 5,000, and for each word, there are like 300 characters at most, right? So for this one, I mean, a brute force way is, of course, we will try to basically try each of the combinations, right? We have each of the combinations of the 2 words, and then we try to concatenate them in 2 ways, right? Basically, put this one on for the first one, and then try this one to be the first one, right? So for that, and then after that, we check if the word is a palindrome. So let's say if this one is like n, this one is m, right? So for that one, to find all the pairs of the words, going to be n squared, right? And then for each of the pairs, we need like m, actually 2m's, right? 2m's to check if that new string is a palindrome. I think this one will also pass, right? Given this kind of 5,000, right? So basically, that's the brute force, but we want to do it better, right? I mean, if we can only loop through this one instead of this 5,000, that'll be better, right? So what we can do is that for each of the words, if we can find all the valid potential the pairs, right? If we can find all the potential pairs for these words, and then all we need to do is that we just need to check if that pair exists in this words list, right? That will basically save us some time because the word itself is only 300 long long, so it's much smaller than the 5,000. And how can we find the then for each of the word, how can we find the valid either prefix or suffix? Because for each of the words, since the other part can be either as after this word, or could be before this word, right? That's why we need to check both of them. So how can we find all the valid possible the other parts, right? So for example, if we have let's say TBC, right? So TBC EXE. For example, if this is the word, okay, and if we were to find these parts, okay, so what are the valid suffix for this one, right? It's gonna be BCT, right? And then also sorry, this one is not BCT. Basically, it's gonna be a CBT, right? And also there's another one, which is the I think XECBT, right? So both this one and this one, they're both are palindromes, right? So then you guys, I think you guys have already find out, right? So in order for us to find all the valid the other parts here, right? We need to check basically if this part, so first how did we get CBT? Basically, we loop through these words, right? And then we check from this I to N if this part is a palindrome. For example, this EXE is a palindrome, right? So which means that from 0 to I, that's a valid prefix. Of course, we will need to reverse this the other part, right? So that's why since the EXE is palindrome, that's why we get TBC, right? So we have TBC, and then once we reach the E here, of course the E itself is also like a palindrome, right? That's how we get the other part, which is the TBC BE, right? So if we reverse it, we get this one and this one, right? So that's how we get the the other part. We can call it like a prefix. Yeah, basically that's a valid prefix, right? To be able to form a palindrome after reversing this valid prefix and to the end, right? Same thing for this part, right? So if we were trying to find this part, obviously we'll need to find from the other part, which is we need to find the valid suffix, right? So and then obviously even in order to find the other parts, we just need to we can simply reverse these words, right? We can reverse no, we don't have to reverse it. We simply we still loop through from the beginning, but we check the other parts. We check the this parts. No, sorry. We check this parts. If this part is like a palindrome, right? And then the remaining is a valid suffix, and then we also need to reverse it. Okay. So and now for each of the word, right, we can have like a list of valid prefix or suffix, and the only thing left is that we just need to check, right? If any of this prefix or suffix exists in the in this words dictionary. If it exists, then we know, okay, we find like a match, right? Because the length of the word is only 300. That's why the length of this word of this valid prefix or suffix is also bound to 300, right? That's why we can reduce this time complexity. So we can start coding then. So first I'm going to have like a word dictionary. It's going to be a word and I, since we will be using the word to find the index, right, later on. For I dot words in enumerate, right, words. Okay, and then we have the answer, because this one, right. So now for each of the word, right, each of the word here in enumerate of words, there's a like special case where it's the if the reverse of the word is the same as the word itself, like basically if the reversed word is equal to the word the reversal of the word, then this one might be the answer. Okay. I mean, basically, so we reverse the word and then we check if this reverse word is in this word dictionary. If it is, then we also find like a match, right? So if the reversed word in the word dictionary, right, and the I is not equal to the word dictionary dot reversed word, right, then we know, okay, we find a pair. How we can do this? So basically J is going to be, we can do this one, right? So J is going to be the reversed word dictionary dot reversed, right? If I is not equal to J, right, then we append I and J, okay, right? Because the if the reverse word is the word itself, right, then it's not a valid pair. Okay. Now we need to find some prefix, right? So basically for valid prefix in assuming we have get prefix, okay, we have a word, right? So for each of the valid prefix, remember we need to reverse it, right? So we have a reversed prefix, gonna be the prefix of this. We'll implement that prefix later on, okay? And so similarly for this one, right? If the reverse prefix is in the word dictionary, right, then we can append. So here we don't have to check it because the prefix will definitely be different. It's definitely different as the original word. So we can simply just append the answer here, right? Gonna be this one of this, right? So that's that. And for the suffix, it's very similar, right? Suffix, assuming we have another suffix. So I'll just copy and paste here. Okay, so this one, if this one is in here, but be careful. So here we are, will be concatenating in the reverse order, right? Because here the suffix will be put at the beginning of this word. That's why we are reversing the index here. Okay, and then we return the answer in the end, right? So now let's implement those two helper functions, right? So we have a get prefix, then we have a word, right? This one, so this one returns a list. Okay. So for I in range of length of the word, right? And if the word, so for this one we're checking the from I to N, right? So if this one is equal to the word of if it's equal to the reversed, if this one is part of a palindrome, right? Then we know, okay, so we find a valid prefix. It's going to be a append dot words, right? This one, and then we return the answer. Similarly for the suffix. Okay. But for suffix, we check the other parts, right? Basically, we check from this to I plus 1, right? And here it's going to be also I plus 1. Okay. Here's also I plus 1, right? So I plus 1 to the end, right? Yeah, so that's it, I think. Let's try to run it. Oh, append key arrow. Okay. Suffix. Okay. Okay, cool. So it worked, right? Yeah, I think that's it. So as you guys can see here, so now we have words here, right? So that's the length of n. Let's say this n, this is m. So we have an n at the very top, and for each of n here, we have we'll have this kind of get prefix, right? So the get prefix, the this one, I think it's m square, right? Yeah, I think it's m square, and here we have m, right? Yeah, and the dictionary lookup is all of 1. So that's why, for this solution, it's going to be n times m square instead of n square times m, right? So this one is better. Yep, I think that's it, right? So this one, I think there's also like a prefix tree solutions, but I'm not going to do it at the moment. I think this one is good enough. Okay. Yeah, so pretty straightforward, right? So for each of the word, we pre-calculate. No, yeah, we calculate all the valid uh, this part or all the valid this part, right? And then for each of the candidates, we look it up in the word dictionary. If there is one in the word dictionary, we simply just get the index and then we append to the final answer. Cool. I think that's it. Thank you for watching this video, guys, and stay tuned. See you guys soon. Bye bye.